Okay, welcome to this web seminar under the Master of Computer Science program offered by the Faculty of Computing and Informatics in Multimedia University. I'm Dr. Timothy Yap, okay, from the Faculty of Computing and Informatics. I specialize in data engineering and big data. I'm the faculty's data engineer. I do a lot of corporate training on big data technologies. I also do a lot of consulting work on big data technologies. Today's talk will be on introduction to big data and Hadoop. But before I start with my talk, let me give you a brief overview of our Master of Computer Science program offered by the Faculty of Computing and Informatics. So our Master of Computer Science program is a master by coursework program. The entry requirement is that you need to have a minimum CGPA of 2.75 or equivalent, okay, to enter. However, if you don't meet the 2.75 CGPA, we can still allow you to enter with a CGPA of 2.5, but you need to undergo a rigorous internal assessment process. However, if you still do not meet a minimum CGPA of 2.5, we can also allow you to be accepted into the program if you have a minimum of 5 years working experience in the relevant field. You also need to have an English proficiency requirement. You can have a minimum overall TOEFL score of 550 or 80 if it's internet based. Minimum IELTS band score of 6.0, a credit in a 1119 English exam, or a minimum WET overall band score of 4, okay, or any other qualification which is of equivalent level as determined by the Senate of the University. So for this program, the duration of study is about 1 to 3 years if you are a full-time student, or 2 to 5 years if you are a part-time student. So it depends on how you take your modules and so on and all that, how you arrange your time. Okay, so it's a very flexible program. So if you take a look at our program structure, it is to be conducted over 3 semesters, covering a total of 13 subjects. 1 university subject, 9 core subjects, and 3 elective subjects, totaling to about 42 credit hours. So the core subjects include software quality assurance and testing, low-level design of software, architecture of large software systems, IT research methods, advanced data management, software requirements engineering, service-oriented architecture using web services, as well as a project. These are the elective subjects. So you have interaction design, security in computing, risk management for software-intensive projects, data mining and analytics, data pre-processing and analysis, high-performance computing for big data, software project management. So if you take a look at the last 4 subjects, they are very data science related. So we put a lot of emphasis on data science. So if you are very interested in data science, do join us for this program. As I'm a data engineer myself, okay, I'll be talking a bit on big data technologies, which is also covered in this subject, high performance computing for big data. So we not only offer these subjects, sometimes we also look at the current technology trends. So we will always refresh our subject offerings all the time, okay. We have some subjects such as blockchain technologies in the works. I know this because I'm drafting the syllabus myself. Okay, and then lastly we have the university subject, which is technological innovation and entrepreneurship. Okay, so who is this course for? So if you are looking to enhance your knowledge of software engineering, especially in the design of large software architecture, then this is the course for you. Or you are looking to equip yourself with knowledge of cutting-edge skills, okay, to make it out in the industry, or to keep abreast with current technological trends. please do join this program. Okay, this is very relevant to what you are looking for. Okay. All right, so let me continue with my technical talk. So I'll be talking about introduction to big data and Hadoop. So let us start off with what is big data. So big data is an official term that usually describes a large volume of data. But most of the time this data is unstructured, but it can also be structured. Okay. So it is actually a natural progression from our conventional databases. Why is this so? Is because of the large volume that we have, current databases are not able to store and process this data anymore. Okay. At the same time, we also have data mining methods that is used in data warehouses. Okay. We apply them to big data. All right. But often in a much larger scale. Okay, so typically big data describes any data that exceeds the processing capability and capacity of conventional database systems. Okay, so why is big data important? Okay, from large amounts of data, so we can do analysis such as to identify things such as running costs, execution times, and product deficiencies. So with this information, or with this analysis, or in this insight, a business can typically improve performance, okay, reduce time, and also offer new product offerings. So combining big data with high performance analytics, we can accomplish tasks like, for example, identifying failures, issues and defects in near real time. We can generate unique customer updates based on buying habits. We can also detect behavior before disaster strikes, or even we can estimate stock purchases while minimizing wastage. So the question now is that where is this data coming from? Okay, why do we get so much data nowadays? Because we are living in a digital age. Okay, every digital object, okay, data is being generated by everything surrounding us. Okay, so every digital object, they actually generate data. Okay, we are now very active on social media like Twitter, Facebook, Weibo, and WeChat. So every action that we do on social media generates data. Okay, we have mobile devices such as GPS. They also generate data. Body sensors like your fitness trackers, they also generate data. Nowadays we have IoT sensors that is used to maybe monitor environmental data. They also generate a lot of data. So we get lots of data from many various different sources. So these are some examples of the data sources that we have. I'm sure that you are familiar with some of them, and then you have experience handling this data already. Now, big data makes the difference by not handling just only one type, but all of them at once. That is the challenge. That is where big data technologies come in. Okay, we do this to find correlation between them. Okay, to find a conclusive output result. Okay, so who should implement big data? We have to take note that not every problem can be solved with big data, even though we have large volumes of data. Okay? In some cases, even the traditional method or the conventional method, okay, is probably faster than the big data approach. So know that with big data, we are often trying to infer something unknown. Okay, so we may not be able to actually have an impactful return on investment. The other main thing is that to undergo big data, we requires a lot of manpower, resources, and most importantly, time. The most important thing is also human talent. Okay, so you need a lot of knowledge in order to actually implement big data. Now, who should not implement big data? You or your company is not ready for big data, okay, if you do not have realistic goals or outcomes, or you expect instantaneous results. You see, we have so much data, it is not realistic to get instantaneous results all the time. Okay? You need time to process the data. You also may not have enough data, okay, to process, or you don't know your data. You are very uncertain about your data, or you do not have enough resources, especially manpower or human talent. Okay? Or you want to use big data to replace your existing production systems, such as your business intelligence, okay, systems. That shouldn't be the case. So we look at some of our big data case studies. So if you take a look at Tesco UK, what they have done is that they have placed sensors on their refrigeration units in almost all their stores. Okay? So from that sensors, they are able to use the data generated to actually reduce power usage, okay? And to save costs. Okay. If you take a look at Visa, they use big data analytics to improve customer service, okay, and also to reduce fraud. Amex, American Express, uses big data to predict customer loyalty. They can actually identify customers that will potentially close accounts within 4 months. If you look at our local telcos, most of these telcos actually analyze network requirements using big data technologies, okay, to identify customer usage patterns so that they can offer better packages to their customers. Then Facebook or Twitter, okay, social media companies, they offer live trending feed, okay, which shows the most active posts based on mine data, also through big data technologies. Tesco Malaysia, okay, our own Tesco, okay, apply big data to improve customer service. How? They provide customized coupons to members for better distributions of stock based on demand. So they actually have a 30% increase in customer loyalty and visits. So what's wrong with our traditional databases and data? Actually, there's nothing wrong. It's just the use case may not be suitable. When we talk about traditional databases, we are talking about our relational database management systems, such as SQL Server or MySQL, MariaDB, and so on. So these database systems, they work very well with structured data, with a fixed format that will not change. So data is normally stored in tabular form, okay? And then it conforms to a particular schema, okay? In general, it is very easy to query what you want from these databases. But currently, because of the sheer amount of digital data, digital objects that we have, okay, all these data from these digital objects, they don't actually conform to all this schema, or they don't conform to the format that these databases accept, okay? So we have an example of data inside traditional databases. So you can see that they follow a particular schema, or they follow a particular table or columns and so on and all that. So these are what we call structured data. But a lot of data nowadays are unstructured. They don't follow a certain kind of format or pattern. So what is wrong with big data? Okay, big data is not perfect. It has its own problems too. So the collection and storage and management of this data requires new methods, okay, that a traditional database cannot handle. The big problem is that these data that are coming in, they do not have a consistent structure, or they come in various different formats. And one of the very big problems is that the data is generated at a very, very fast rate. So we can actually identify whether you have a big data problem or not through something what we call the 4 V's. Okay. Before we go into that, we want to know how much data is being generated nowadays. So with this figure from 2012, okay, this is actually quite old, but that time already, 2.5 exabytes of data was already generated daily. Okay, this was from IBM, okay, in the form of text, voice, and video. You take a look at Facebook now. Okay, Facebook users alone now generate 600 terabytes of posts daily. Okay, now storage requirements exceed 300 petabytes. If you take a look at YouTube, okay, YouTube receives over 300 hours of uploaded video data every minute. Look at the sheer amount of data that we have right now. Okay. So now we take a look at what happens in an internet minute. Okay, this is the very recent, this is what we have in 2019. So you take a look in 1 minute, let us take, for example, YouTube. 4.5 million videos are actually viewed, okay, in 1 minute. Or we take a look at Twitter, for example. Actually, in 1 minute, 87,000 people are tweeting, okay, in that 1 minute. Or Facebook. Facebook, we have 1 million people logging in at the same time in that 1 minute. Okay, so this is what happens in an internet minute. So now we come back to the 4 V's. So if you have these 4 V's, then you have a big data problem. Some companies may mention 5 V's, some companies may mention 6 V's, but with these 4 V's, we can actually identify, this is already enough to identify that you have a big data problem. So of course, the first V is volume, okay, the scale of data, the amount of data that you have, okay, that's volume. The second one is variety, okay, different types of data. You have different data from different sources that have different structures, different patterns, and so on. They don't conform to a single format, okay. The third one is velocity. Data is being generated very fast, at a very fast pace. So how do we keep up with this generation of data? Okay. Then lastly, we have veracity. Veracity refers to the uncertainty of data. Can your data be trusted? Are they trustworthy or not? That's veracity. Okay. So if you have these 4 V's, you have a big data problem. So how can we handle the V's, the 4 V's? So a traditional database can no longer handle big data efficiently. Even if it could, it can never scale, okay, to accommodate the ever-increasing amount of data coming in. So a more efficient way has to be introduced. So this is where the Hadoop architecture comes in. So Hadoop allows us to scale and to process big data. Okay, it is a processing framework which we'll discuss in the next topic. Okay, so in the next topic, we'll discuss what is actually Hadoop. Okay, so Hadoop is actually an open source programming framework intended for distributed storage and processing of large amounts of data. So it was actually created by Doug Cutting, okay, and has its origins from research and development on Nudge. Nudge was actually a search engine that Doug Cutting was working on. So what happened was that when he was working on Nudge, he found that he cannot scale. Okay, he's not able to process data efficiently. Coincidentally, at that same time, Google released a white paper on their MapReduce processing framework. So from there, he was able to apply that, okay, to process large amounts of data. So that is where he came out with the product Hadoop, okay, to process large amounts of data to find ways, okay, to implement his search engine Nudge. Okay. So the Hadoop framework is built using Java, but it can support many different languages. Okay. It's designed to run on multiple machines, okay, with its own type of memory, storage, and processing power, but not limited to type. So you don't have to use homogeneous equipment. You can use heterogeneous equipment, meaning that your equipment can be of different brand, different specs, okay, different type, okay. And then one thing good about Hadoop is that it allows you to use commodity hardware. Commodity hardware means that hardware that you can buy off the shelf. Okay. So when data is loaded into Hadoop, what happens is that the framework divides the data into multiple pieces, which are spread and replicated across all the machines. So to run a job, each piece of data is processed individually on the machine that is stored, okay, instead of retrieving, combining, and working on a single large data set. Okay, this is common in traditional systems. Okay. So there are three main components of Hadoop. You have the clients, the masters, and the slaves. So the clients are actually the users of the system, and they submit data and jobs into the system. So the masters consist of machines. They are sometimes called name nodes or job trackers. What they do is that they keep track of the job that is being sent into the system. Okay, they manage the jobs, they manage the workers. Last but not least, you have the slabs, which are also sometimes called data nodes or task trackers. These are actually the worker nodes, okay, the ones that are actually performing the processing and storage. So if you take a look at this figure, you can see that the clients will submit jobs to the masters, the name nodes in this case, and then the masters will then distribute the job over to the slaves or the worker nodes. So the processing framework is called MapReduce, and then the storage is called HDFS, the Hadoop Distributed File System. So if we compare Hadoop and the traditional business intelligence or data warehouse, you can see that, okay, typically your databases are only one or two servers, okay, and then you access your data through your switches, through your application servers, and so on. But if you take a look at Hadoop with analytics, you will have your master nodes, and then you will have many slave nodes. And then the jobs and storage, the jobs are done by the slave nodes. The data are also stored on the slave nodes. So you can see that the architecture is very different. So if you take a look here in more detail, data warehouses are mostly SQL databases. They have high availability. They are good for enterprises, good for structured data. So typically implements your storage area network or network attached storage. But if you take a look at Hadoop, okay, it supports additional data types. The Hadoop distributed file systems allow this. It also has high HA, high availability. But computing and storage are done on the same hardware. It's very good for semi and unstructured data. Okay. It can work with network storage, but it's not required. Okay, so we take a look at the Hadoop framework now. So for the Hadoop framework, the very core component of Hadoop is the HDFS for storage, the Hadoop Distributed File System. So it provides a scalable and reliable data storage. Okay, you can use it to span large clusters of commodity servers, so that's why it's able to handle large volumes of data. The next one is we have the processing framework. This is a batch processing, so this is called MapReduce. So it allows you to write programs to process data in parallel over thousands of machines. That's MapReduce. Then we have Yarn. Yarn is actually the resource manager because you are distributing data over large amounts of machines. You are processing your data over large amounts of machines. You need a resource manager to actually manage the jobs and so on. So Yarn is the resource manager. Then of course you have some other third-party tools that allows you to actually do queries in fourth generation languages. So you can actually use SQL if you want. You can have tools like Hive Okay, allows you to use SQL to actually query and process your data in HDFS. You have tools like Pig that allows you to write scripts. Okay, HBase is a database that sits on top of HDFS. It supports multi-dimensional data. If you need real-time processing, you can use Storm or Spark. These are used for streaming data sets. If you need interoperability, you need to import data into Hadoop. You can use tools like Scoop. Scoop allows you to import data from traditional databases into Hadoop. Or you need to import logs and so on, or streaming data, you can use Flume and your traditional network file system. If you need security, sometimes you don't want people to access certain data in Hadoop. You can harden your data through Knox or Atlas. Okay. Then you need some other framework to actually help you with the processing of data. So you have graphical interfaces such as Hue, workflow management such as Uzi, and so on. Okay, so this is more or less the Hadoop ecosystem. So where can I get Hadoop? So various vendors supply ready-to-use options and commercial options. Of course, you can have the open source community version as well. Some of the bigger names in Hadoop will be Cloudera and Hortonworks, and also MapR. Okay. These are the big players in Hadoop. If you like to use Hadoop on the cloud, you have products such as Microsoft HD Insight. You can actually deploy Hadoop clusters on their Azure cloud solutions. Okay. So typical Hadoop setups. Okay, you can have a single node cluster, but this is just only for testing. Okay, for production, you don't actually get any benefit from using a single node. Okay, because on a single node, you are not able to store large amounts of data. You are not able to process the data parallelly. Okay, typically, we would go for a multi-node cluster. So minimum 2 nodes, 1 data, and 2 name nodes. So these are some examples of production clusters. Here we have one with, from Yahoo. This was in 2007, so it has about 42,000 machines. Here we have the one from eBay, their Hadoop cluster. We have also another one from Gaia. It is a weather processing center, okay, in the UK. We have the Facebook one. So Facebook also has its own Hadoop cluster. So this was in 2010. So that time they have somewhat about 2,000 machines, okay, 2,000 nodes in their cluster. Okay. All right. So that is the end of my presentation. I'll stop for a commercial break now. Then we'll go on with our Q&A in a while. Okay, welcome back. I have a question from Nizam. He's an electrical engineer. He's working in networking and ICT. And then he's asking whether this course is suitable for learning programming, information, and big data. Yes. It will give you a lot of value to your current job, okay? Because now you are working on networking and ICT. By coming into this course, you will learn more on how to actually upgrade your skills. You actually add to your current repertoire, okay? Because if you are very much interested in programming, this course actually caters into software engineering. So you learn how to actually build software in a large scale. Okay, you learn how to manage project, to actually build all these systems and so on and all that. Okay, I hope you can I hope that answers your question. Okay, thank you very much. So if you take a look at our program structure, Nizam, these are some of the subjects that we offer. So I think a lot of them are very relevant to what you want to do. If you take a look at software quality assurance and testing, low-level design of software, architecture of large software system, this actually allows you to program or build enterprise-ready applications. If you are very interested in big data, if you take a look at the last 4 subjects here, data mining and analytics, data preprocessing, or high-performance computing for big data, this will actually prepare you for big data analytics. So we are actually very focused on data science and data engineering. Okay, right. Okay, so you're asking which one is more suitable. Which one is what is the preference? What's the difference between a data engineer and a data scientist? That's a very good question. Okay, so technically, a data engineer prepares the data for the data scientist to use. Okay, as a data scientist, I need data to work with. So only then I can get my insights. I'm able to infer something from my data. But then, in order to actually do that, you must get the data first. So that's the job of the data engineer. So the data engineer gets the data from the sources that the data scientist needs, and then prepare the data, process it, clean it, prepares it into the format that the data scientist needs. Okay? Of course, there's a technical difference between data engineering and data science. But nowadays, as a data scientist, you need to have the skills of a data engineer too. That is the current trend now. You cannot just work on your analytics and on your prediction alone. You need to also have the skill of a data engineer, because you also need to know where your data comes from. You also need to know how to clean and prepare your data for your analytics and so on. So both skills are very important. If you want to be a data scientist, you also need data engineering skills. Yes, Nizam, yes.
Can I explore other electives that may relate to networking as well, other than those listed?
Oh, I see. Okay. That's also a very good question. So if you take a look at the elective subjects, we don't have one which is focused on networking at the moment. So these are what we have currently. Maybe in the future we may offer a few more that is based on networking. At the same time, in our faculty, we also have our certification programs. So we also actually offer Cisco or certification. So you can also go for some of these courses offered by Cisco. Some of our lecturers are actually Cisco certified trainers. I hope that answers your question, Nizam. Okay, Nizam, your question is that you do not have any computer science knowledge. Is it too late for you to take this course from scratch? Actually, no. Why is this so? Is because you have working experience, so that actually counts to your advantage, even though you do not have any computer science background. So that shouldn't be a problem. And then we have a lot of people from industry coming in at 40, 45, some even 50, coming in to take this course. So it shouldn't be a problem. Okay, I'm sure this will actually add value to your job. I think this will also allow you to grow, okay, in the job market, okay, by taking this course. I hope that answers your question, Nizam. All right, so we shall stop here. Okay, so I will end my technical talk here. I hope you will get to know more about MMU, our faculty, the Faculty of Computing and Informatics, and also know more about our Master in Computer Science program, okay, specializing in software engineering and software architecture. Please do join us. Thank you very much. Hope to see you in future seminars.